Now moving on to the 10th bit of 5th question. Here he asked us to prove that 1 plus tan square a by 1 plus cot square a is equal to 1 minus tan a by 1 minus cot a whole square is equal to tan square a. In order to prove this equality, let us prove that first expression is equal to last expression and second expression is equal to third expression. Thereby we can say that all the three expressions are equal. So let us consider the first part, that is 1 plus tan square a by 1 plus cot square a, which is equal to 1 plus tan square a whole divided by 1 plus cot square a can be written as 1 by tan a whole square, that is nothing but 1 by tan square a. So now that will be equal to 1 plus tan square a whole divided by, let us take the LCM as tan square a in the denominator, then the numerator of the denominator becomes tan square a plus 1. Here in the numerator and denominator 1 plus tan square a is common and that will be cancelled. So finally we are left out with tan square a. So here we proved that 1 plus tan square a by 1 plus cot square a is equal to tan square a, which is our first proof. And secondly, let us consider 1 minus tan a by 1 minus cot a whole square, which is equal to 1 minus tan a by 1 minus cot a can be written as 1 by tan a whole square, that is equal to 1 minus tan a by, if we take tan a as LCM here, then the denominator becomes tan a minus 1 whole square, which is equal to, let us separate the tan a here, then it becomes tan a whole square, which is nothing but tan square a into 1 minus tan a by, if we take minus common in this, then it becomes 1 minus tan a as denominator whole square, which is equal to tan square a into, here this will be cancelled and this will be cancelled as it is common in numerator and denominator, and we are left out with minus 1 whole square, which is equal to minus 1 whole square is nothing but 1 and 1 into tan square a is tan square a again. So 1 minus tan a whole square by 1 minus cot a, and whole square is for both, is equal to tan square a. Let this be our second equation. From 1 and 2 we can say that 1 plus tan square a by 1 plus cot square a is equal to 1 minus tan a by 1 minus cot a whole square is nothing but tan square a. Now moving on to the 8th bit of 5th problem, let us find the solution for this. Here he has given an equation, that is sin a plus cosecant a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. In order to prove this, let us initially consider the left hand side. That is sin a plus cosecant a whole square plus cos a plus secant a whole square, which is equal to, this is in the form of a plus b whole square and this is also in the form of a plus b whole square. Let us apply the formula that a plus b whole square is equal to a square plus b square plus 2ab then we get here sine square A plus cosecant square A plus 2 sin A into cosecant A. Here this can be written as cos square A plus secant square A plus 2 times cos A into secant A. That is equal to, let us write sin square A and cos square A together, plus cosecant square A plus secant square A together, plus here 2 times sin A times cos A is nothing but 2, as sin A into cosecant A is 2, plus similarly 2 times cos A into secant A is equal to 2, as cos A into secant A is nothing but 1. So finally here, as we know from the identity 1 that sin square A plus cos square A is equal to 1, by replacing it we get 1 plus 2 plus 2, that is 5, plus cosecant square A plus secant square A, which is equal to 5 plus, from the two identities, that cosecant square A is equal to 1 plus cot square A and secant square A is equal to 1 plus tan square A. By substituting it here, we get the expression in terms of tan square A and cot square A. That is, cosecant square A can be replaced by 1 plus cot square A plus secant square A can be replaced by 1 plus tan square A. That will be equal to 5 plus 1 plus 1 is nothing but 7 plus cot square A plus tan square A, which is nothing but our right hand side. So here we got LHS is equal to RHS, and hence we proved that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Moving on to the fourth bit of the fifth question. Here he has given an equality of two expressions, that is 1 plus secant A by secant A is equal to sin square A by 1 minus cos A. So let us move on to the solution. As he asked us to prove the equality, let us consider the left hand side. And simplify it, then right hand side and then simplify it. If they are equal, then the equality is right. So in the left hand side, the given expression is 1 by secant A whole divided by secant A. That will be equal to 1 plus secant A can be written as 1 by cos A whole divided by secant A here also can be written as 1 by cos A, which is equal to, let us take cos A as LCM in the numerator, then we get cos A plus 1 in the numerator divided by cos A whole divided by 1 by cos A. Here in the denominator of the numerator we have cos A as common, so these two will be cancelled, and finally we are just left out with cos A plus 1, which can be written as 1 plus cos A. So here the simplified form of left hand side is 1 plus cos A. Similarly, let us also simplify right hand side, that is sin square A whole divided by 1 minus cos A, which is equal to, here we have an identity that sin square A plus cos square A is equal to 1, which implies sin square A is equal to 1 minus cos square A. So by replacing sin square A as 1 minus cos square A divided by 1 minus cos A, that is equal to, here this can be written as 1 square minus cos square A, which is in the form of A square minus B square, that can be written as A minus B, that is 1 minus cos A, into A plus B, that is 1 plus cos A whole divided by 1 minus cos A. Here in the numerator and denominator we have 1 minus cos A as common and that will be cancelled, and finally we are left out with 1 plus cos A. So the simplified form of LHS is equal to the simplified form of RHS. So the equality 1 plus secant A by secant A is equal to sin square A by 1 minus cos A is correct. Now moving on to the 7th bit of 5th problem. He has asked us to prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. In order to prove this, let us consider the left hand side, that is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta, that is equal to, in the numerator let us take sin theta common, then we get the numerator as sin theta into 1 minus 2 sin square theta divided by, in the denominator let us take cos theta as common, then we get the denominator as cos theta into 2 cos square theta minus 1, that is equal to, if we write sin theta by cos theta separately, then it is nothing but tan theta into 1 minus 2 into, here we have an identity that sin square theta plus cos square theta is equal to 1, which implies sin square theta is equal to 1 minus cos square theta. Let us substitute here, then we get 2 times 1 minus cos square theta divided by 2 cos square theta minus 1, which is equal to tan theta into 1 minus 2 times 1 is 2 and minus 2 times 2 square cos theta is plus 2 cos square theta divided by 2 cos square theta minus 1, which will be equal to tan theta times, here by rearranging the terms we get 2 cos square theta minus 1 by 2 cos square theta minus 1. Here in the numerator and denominator we have 2 cos square theta minus 1 as common, which will be cancelled, and finally we are left out with tan theta, which is our right hand side. So here as LHS is equal to RHS, we can say that sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta is equal to tan theta.